Okay, so today we're doing the second lesson for functions. So we're talking about domain and range. Again, this should be a review from last year, hopefully. You talked about this some last year. I don't know how much you remember, so hopefully when we go over it today, that'll help. So the first thing we're going to do is define these two words. So we've got domain. And the domain is the set of all possible input or x values for a function. The set of all possible input x values for a function. That's domain. And then range is its counterpart. And range is the set of all possible output y values for a function. The set of all possible output y values for a function is the range. Now we've already talked about two things that go with input and output. Do y'all remember what those were? If not, maybe flip back and look at your vocab from the last page of last time. Independent and dependent variables. Okay, independent goes with input. Domain also goes with input. Dependent goes with output. Range also goes with output. So there's like a lot of things that all kind of go together. So we're going to draw this picture that it's just kind of a silly picture, but it's going to help you remember which one's which. So I'm going to introduce you to my friends Dixie and Dory. So first thing I need you to do is draw a big X like this. And then draw a big Y like this. So draw you a big X and a big Y, yes. Okay, so there's the X and there's the Y. So draw a big X and a big Y. And then I need you to give them some feet down here. I know. Just put those shoes down there on the bottom. And then they're going to have faces. Hold on, we'll talk about that. That's kind of important. Okay, Dixie and Dory are cheerleaders, so I'm going to put pom-poms in their hands.
I did this thing yesterday. I'm doing drinks.
So they're cheerleaders.
It looks like a tree.
It is a little bit sad, yeah. Okay, so here's the deal. This one's name is Dixie, D-I-X-I. And this one's name is Dory, D-O-R-Y. And have y'all ever heard the term or heard the saying that someone could stand on their own 2 feet? Like if I say my brother Robert can stand on his own 2 feet, what does that mean?
He can take care of himself.
He can take care of himself. He's independent. He can pay the bills. He can cook. He can handle himself, right? That's what that means. He can stand on his own 2 feet. He's independent. So which one of these is independent? Dixie. Dixie's independent. She can stand on her own 2 feet. Dory, not so much. She's only got one leg, right? She can't really stand on her own 2 feet. She needs help or else she's going to fall over. All right, she's going to have help or support. She's dependent on something else or else she'll fall over. So Dixie is independent. Let's do this in a different color. Dixie is independent. What else goes with independent? Domain. Domain goes with independent. And what else goes with independent? The x value, we're just going to leave that. And then what? Input. So Dixie stands for domain, independent, x, input. All those things go together. And that's Dixie. So Dory's not independent. What is she? Dependent. And it's even like defining Dory, because you know that Dory needs a lot of help to stay out of trouble and be where she needs to be.
She has like
Short-term memory loss, so she needs help, right? So she's a little dependent on others to take care of her sometimes. So same kind of thing. Okay, what would the O stand for? Output. What would the R stand for? Range. The R in Dory. And then Y is just for the Y value. Okay, the reason they're cheerleaders is because later on we're going to talk about slope. And I know y'all did some slope last year, right?
Yeah.
And on the slope, the X is always on the bottom and the Y is always on the top.
Yeah.
It's kind of important for cheerleaders, for the most independent, most stable one, maybe the one with 2 legs, to be on the bottom, right? If I have a one-legged cheerleader on the bottom of the pyramid, we're going to have a problem. Okay, now, she can be a flyer and she can be on top and she can stand on one leg as long as the person can hold her up, right? And that's okay because there's all kinds of tricks where they do that. And they lift their leg up in the air and do the splits and I don't know what all they do. But so Dory can be on top, but she cannot be on bottom and be a very good stable support. So when we do slope, it's going to help you remember that she needs to stand on her own 2 feet on bottom because we don't need a one-legged cheerleader on the bottom of the pyramid because it would be bad for everyone. So this is just kind of a goofy picture to kind of help you remember which ones go with what. Dixie is domain, independent, input, X. Dory is dependent, output, range, and Y. Okay? So if you're not sure which ones go with which, think of Dixie and Dory, or flip back to this page. All right, so we're going to use what we know to see if we can figure out domain and range for a couple of examples. So our first example is going to be a set of points. So I've got -5, -2. -1, 6. 2, 12. And 5, 18. And we're putting the squigglies on the outside to make it appear that this is a full group. Okay, which letter or which coordinate does the domain go with? Domain is all the x's. Okay, so I need to look at the x values. I need to look at the x values. I've got this one, this one, this one, and this one. That's going to be my domain. So all I have to do is write those numbers. -5, -1, 2, and 5. There's your domain. And then we're going to do range. And your range is all the y numbers. So you've got this one, this one, this one, and this one. There's your range. And so would this be a function? Yes, because what did you just say, Sengo? None of the x's repeat. So yes, it's a function. If it asks you if it's a function, then yes, this one is. Okay, that's a pretty easy way to figure out domain and range. You're just looking at the points.
Bless you. Thank you. You're welcome.
All right, so we did some like this the other day. Y equals 7 minus 3x, where they gave us like a rule, a function rule is what this is called. And they gave us domain. And they want us to figure out the range. So they want us to figure out the range using the domain. what in the world am I going to do with the domain numbers to figure out the range? Plug them in for x, because domain is really all the what? These are x values. So if I can evaluate this function rule for -2, in other words, plug that -2 in right there, I should be able to figure out the range. So you got your calculators. You're just going to go 7 minus 3 parentheses, plug in your x number. You get you plug in a -2. So tell me what you get. You don't get negative. You get positive what? 13. So my first answer on range is 13. Right? All right, next. I'm going to plug in 1.
4.
You're going to get a positive 4. And then I'm going to plug in 4. -5. And last but not least, we're going to plug in the 6.
-11.
-11. There's my range. And I'm going in the order that I plugged these in. Okay, I'm putting it in the same order, because that's how you know what goes with what. Because if I wanted to write the ordered pairs now, I could. -2, 13, 1, 4, 4, -5, 6, -11. Okay? Make sense? Okay, let's do one though. What if they flip it on you and they give you the range and not the domain? So, if I have y equals 2x squared, they give me the range this time, and they're wanting the domain. Let's move that a little bit. Okay, range goes with the y numbers, the coordinates for the y. So these are y numbers. So this time, instead of evaluating for x, I need to evaluate for y. If you plug it in the wrong spot, you're substituting in for the completely wrong position. That's like putting your kicker in for center. That's not a good idea. Okay, it's just not. Okay, so we're going to take these and we're going to plug them in for the y value over here. So let's put 8 equals 2x squared. Now, what do I do with that? How do I solve that for x? What's the first thing you might do? Divide by 2. So the first thing I'm going to do is divide by 2. X squared equals 4. Now think back to when you did lots of Pythagorean theorem.
Oh my gosh.
You got to take the what? You got to take the square root of these two. So x is going to be the square root of 4. Or what does x equal? What's the square root of 4? 2. Because 2 times 2 is 4. So your first domain number is 2.
Wait, so that's all that looks like a check mark with
That's a square root, yes.
Oh, okay. I didn't know that like slash.
Okay, so we're going to try 18 now. So if I have 18 equals 2x squared, y'all see if you can work that one out and get the next answer.
18 equals 2x squared.
Don't say it out loud. Let everybody kind of process, because some people are process at different speeds than you do. Are you working on plugging in 18? Table 1 over there. Hello? I need you doing this.
Would it be 3?
Okay, you should get 3 on this one. When you divide by 2, you get 9 equals x squared, and then when you take the square root, you get 3. Do 32. Plug 32 in for y.
4.
Square root of 9. Okay, so on that one you should get the square root of 16 equals x, and what's the square root of 16?
4.
4. So my last domain number is
4.
4.
So we find the square root of x or y, and then whatever that is, we take the square root of it or something?
Right. If your answer ends up being x squared equals something, like right here, if you ever have that situation right there, where x squared is equal to something, you have to take the square root of it to figure out what just x is. Okay, any other questions about this one? Because there are a couple on your assignment like this.
That's easy.
Okay, all right, so moving right along, we're going to do a couple more vocabulary, and then we're going to cut out some stuff out of our notes page. Okay, so the two words we're going to do, one of them is discrete domain. And this is probably brand new. I don't think y'all talked about this last year. I don't really know, but I don't think you did. Discrete domain. Okay, there's two types of domain, and we're only looking at the domain. We don't really care about the range on this one. You'll learn that domain and the x is really like the most important, most focused on thing. Okay, so discrete domain. This is when there's only specific values. So we're going to say specific points that do not include intervals between. Specific points that do not include intervals between them. Okay, this is kind of like when you're counting something usually. Not always, but usually. So like if I'm counting a number of tickets, I can have 1 ticket, 2 tickets, 3 tickets. I can't have 3.16 tickets. Like that's not going to work. So I can only have whole numbers for that. But it's not necessarily always whole numbers. What if I'm counting quarters, and quarters are worth how much? 25 cents. So I could do 25 cents, 50 cents, 75 cents, $1. I can't do, if I'm counting a stack of quarters and I'm counting my money, I can't do 0.33. That's not going to happen because it's quarters. Okay, so it can be decimals, it can be fractions, but it's only specific values and it doesn't count the stuff between there.
What about if you're like using like a liquid type measurement?
Okay, so that's going to be the next definition. But so just a second, we'll get to that. So discrete is like if it only takes into account specific points and nothing else matters between those points. So on a graph, if it's just specific points and there's not lines drawn between, it's always discrete. Okay? I really need that table over there to pay attention, or else I'm going to have to adjust the seating chart. Okay, so the next one is continuous domain. And this is what Joey was just saying. Continuous is like if you're measuring something, like a liquid measurement. You can't measure 1 cup and then suddenly skip and go to 2 cups. Okay? So on measurement, it's always going to be continuous. Hold on just a second.
Can you stop it?
Okay. Sorry about that. Okay, so continuous is like, on an interval, it includes every single thing. So it includes everything over an interval. So over a certain distance or period of time or whatever, it includes everything. So if you're talking about mileage, you don't jump in your car from mile 1 to mile 2. Even though maybe that's all you're counting on, your odometer or something. There's millimeters in between there. There's all kinds of space in between there, and you had to drive across all that to get to the second mile, right? You can't just skip from mile 1 to mile 2. All that distance between counts. If I'm weighing something or if I'm measuring something in a measuring cup, all the stuff in between counts. Okay, when I'm pouring water into something, I can't just, it just doesn't glob from 1 cup and then skip and then suddenly poof, there's 2 cups. It builds up. So all that in between counts. So if it's connected on the graph, if there's a line, it's going to be continuous. And speaking of that, on graphs, you have 6 graphs on your paper. So I need you to cut those out in one big block. Leave the domain and range at the bottom. We're not going to use that table that's at the very top, so you can cut that off. So I need all 6 graphs cut out with the domain and range that's underneath it. So you're going to glue all 6 graphs down just like this. Cut all 6 of them out in one big block.
I lost my name.
Going down individually. Goes up.
Wait, it's 8.
Okay, let's get those glued down so that we can get the rest of these notes because you have an activity to do that's due before you walk out the door. Yes, you're going to need that. Huh? Yes. What kind of? Okay, so on this first one, it's got a bunch of dots. And in order for us to figure out domain and range, we need to know what those points are. So we're going to have to name the coordinates. So anytime you have that, find some spot somewhere close to it and go ahead and start naming those points. So I'm just going to do a table out to the side. Just cut them out and put it at the bottom of it. Okay, so I'm just going to do a table out to the side. And we're going to name these 4 points. And when I name points off a graph, I always put an X over that point so I know I've already done that one. These look like they got off a little bit. They were supposed to be on the actual corners, but we're going to pretend like they're on the corners, like they're supposed to be. All right, so on this one, I've got 1, 2, 3, -4, -3 is this first one over here. Let me zoom in for these so y'all can see. A little better. There you go. -4, -3 is that first one. And then this one right beside it kind of is -1, 0. And then I've got +1, 2, 3, 4, +3. And then this one is positive, let's see, that's 4, so 5, 6, 7, 8. 4, 5, 6, 7. So +8, -8 is that last one. So there's my points. If you'll do it in a table like this, it's super easy to write the domain and range because it's already split up for you. Like you already have them in their own little sections. So domain is all the X numbers. So it's all these ones on the left. -4, -1, 4, and 8. And then the range is all the y numbers, -3, 0, 3, and -8. And then it asks me, is this graph continuous or is this graph discrete? Is it just specific points or does it count all the distance between the points? Specific points, so that makes it discrete. This particular graph is discrete. Most of your graphs will be continuous, but not always. Occasionally you'll have ones that are discrete. Okay, that's the first one. The second one, I'm not going to move this all the way over so y'all can still see the first one. The second one has 2 endpoints. I need to know what those 2 endpoints are, so we're going to have to name those 2. So this one down here is -7, -6. So -7, -6. And then the one that's at the top is +7. +8. So -7, -6, and +7, +8. So before we do domain and range, tell me, is this graph on this interval, is this graph discrete or continuous?
Continuous.
Continuous. It's a solid line. All this in between counts.
So the range is 8.
Hold on. So we're going to go ahead and put your squigglies there. What are the 2 x numbers I'm dealing with?
-7 and 7.
-7 and +7. So when you look at domain, find the 2 x numbers. They need to go least to greatest. So -7 comes first. +7 goes at the end. And you're dealing with all the x's in between there. So this is how that's written. X goes in the middle. And there's arrows to the left between the letter and the number. So it looks kind of like those compound inequalities that we wrote. Okay, one thing I've got to look at though. Do I need to underline any arrows? And how do I know if I do? I need to underline one of them by the -7. Why? That dot is colored in, so this arrow needs to be underlined to match. So be careful with that. So if it's an open circle, if it's not colored in, you don't underline it. If it is colored in, you do.
How you know if you have colored in?
It's already colored in. Like it's on the graph, whatever it is already. Okay, so the range, what 2 numbers are we dealing with the range?
-6 and 8.
-6 and 8. So -6 is smaller, so it comes first. 8 is bigger. Same exact thing except for we're doing y instead of x. Arrows to the left. They always, always, always go to the left as long as you do least to greatest. Okay, so which one gets underlined? The -6 or the +8? -6. There's your domain and range. Okay, look at this third one.
Oh.
Okay, this one's kind of weird looking. It's like this weird squiggle line, right? We still need to name the 2 points. This top point up here is a -7, +5. -7, +5. And the bottom one is 6, +6, -9. Okay, before I do domain and range, let's look at it on this interval. Is this continuous or discrete? Continuous. It's all connected. So continuous. I know X is going to go in the middle, and I know there's going to be arrows that point to the left on each side of it. So I'm going to go ahead and do that. It's always to the left. Just think of Beyonce. To Always to the left. All right. What are the two numbers I'm dealing with x?
-7, 6.
-7, +6. -7 is smaller. +6 is bigger. Do either one of those need to be underlined? The 6. Okay, so look at the range. What are my two y numbers for range?
-5 and -9.
5 and -9. So I know you can kind of set it up like this. But -9 is smaller, so I'm going to have to flip-flop a little bit. -9 has to go here. 5 has to go here. So which one gets underlined?
The negative.
The -9. So this time the underlined one is on the other side.
This is, where are you getting 5 from?
The point up here. It's the y value for this point up here,
Oh,
and the y value for the point right here. So I need the two y numbers for the for the range. I need the two x numbers for the domain.
I mean,
Okay, so you got to find those 2 points, and then you can figure out domain and range. Okay, the last 3 are a little bit easier. You don't have to worry as much about open circles and closed circles and all that stuff. All right, look at the one that's the circle. First of all, is this a continuous or discrete? Continuous. It's solid circle. It's continuous. Okay, it does not have endpoints, technically. But domain covers all the what? X's. So I'm going to go ahead and do X in the middle, and I'm going to go ahead and put my arrows. Because I know it's going from one point on the X to another point on the X. Because the circle may not have endpoints, but I know it stops right here and right here. That's how far wide it is. Does that make sense to y'all? It goes from that side on the left to this side on the right. That's how far it is. I need to know what those two numbers are on the x-axis.
It's going to be negative and a positive.
One's a negative, one's a positive. What numbers, though?
I think it's 5.
I think I have 6. -6. Wait, 1, 2, 3, 4, 5. -6. So it goes from -6 to +6. And since there's no like open circles anywhere, we need to underline both of these. Since it's a solid line, if it was a dotted line, we would leave them without an underline, but it's solid, so we're just going to underline them. So set up your range. Y in the middle. Arrows to the left. How am I going to figure out the range, the y values?
Did you go down?
Up and down, right? So I need the smallest one first, so that's the one, the down, this one, and then this one. So figure out those two numbers. I'm figuring out how far up and down it goes now. What's the lowest number? -8. What's the highest?
4.
+4. That's the distance it covers on the y. So the domain is how far it covers on the x. The range is how far it covers on the y. That's what you're looking at. And the next two have some things in it that make them a lot easier. So on the next one, this is a parabola. And I told you we'll be looking at this graph quite a bit, especially when we get to quadratics. But what is on the end of this graph? Arrows. What do those arrows mean?
Keeps going.
It goes on forever, right? So this thing on, well, first of all, is it continuous or discrete? Continuous. Okay, you know domain is going to be x's, but we're just going to leave it like that for a second. Don't write anything inside there yet. So if it goes on and on forever and it's kind of pointing outward, that means it gets wider and wider and wider and wider and wider. Is there an end spot where I can say it covers from here to here on the x? No, it's going to get wider forever. There's no way I can like stop it. So if it goes on and on forever, it's basically covering all the x's. That's all real numbers.
All real numbers.
Yes. So you just put the R.
Discrete means like it's not in a certain, like it's not in like a line or whatever, right? It's just like all over the place.
Discrete means it's just certain points only.
Yeah, that's what I meant. Like, it's just, yeah.
Right. Yeah, like if it's just certain points but not anything connected. Nothing's really connected on discrete. Okay, on the range on this one, on the y's. Does it go up and down forever? Okay, it goes up forever, but does it go down forever? No, there's a stopping point right here. Where does it stop down there? -8? Okay, that means that my range is all the y's that are greater than or equal to that -8. It starts at -8 and gets bigger. So it's all the y numbers greater than or equal to -8. It goes up forever, so I don't have to do an endpoint there. I just have to have the starting point. If it was flipped upside down, then it would be all the y's less than or equal to, because it would go down. Okay, look at that last one. There's arrows on both ends. Does it go left to right forever and get bigger and bigger and bigger? Yeah, it's going to eventually. Like, there's no way for me to say where it stops on the x's. So what's my domain?
All real numbers.
All real numbers. What about up and down?
All real numbers.
All real numbers. And then is this one continuous or discrete? Also continuous. Okay, so you have 4 little word problems. Just leave them all stuck together. You don't need that much room. We're not going to do one of them, but it's right in the middle, so I didn't want you to have to cut them all apart. So glue those 4 word problems down real quick.
Wait, are we doing all of them?
No, we're not doing all of them. But the one that I don't want to do is kind of in the middle, so I didn't want to have you cut them all apart. Because there are a couple questions like this on your assignments. I want to make sure you get this. I think we're just going to do 1 and 3 is the 2 that we're going to look at. So number 1 says, let me read it to you. Sheila rented a truck to move this last weekend. She had to pay $40 for the truck and then 65 cents per mile she drove. If she only had $100 to spend, what is a reasonable domain and range for this situation? Okay, so it's asking you to figure out what would be reasonable for input, what would be reasonable for output. Yeah, get one out of the top drawer that's right there. Just throw that one. Okay. So before you can do anything on these word problems, you have to figure out what your 2 variables are. So the little word per that I told you the other day is kind of important because it shows you your 2 variables on each side of it. Okay, so this one is money, this one is miles. There's my 2 variables, money and miles. How much money she spends depends on how many miles she drives, right?
Yeah.
That makes sense? So this one, money is dependent, miles is independent, which makes money the range and miles the domain. Now you don't necessarily have to write that all out every time, but you need to know it. If you don't understand that, you can't figure out domain and range. So if I have domain here, which is really the number of miles, and I have range, which is really how much money she spends. Which one of those 2 things did they give you more information about in this problem? Did they give you more information about money or more information about how many miles?
Money.
They gave you more information about money. So that's the one you're going to be able to figure out easier. So do that one first, which is range. She has to pay at least how much? At least 40. So she has to pay at least 40. And at most 100. Y's in the middle, arrows to the left. That's how much money from least to greatest that she's paying. That one you knew most of the information, they gave it to you in the problem, right? Okay, what about domain?
0.65.
65 cents per mile, so we can figure out how many miles she drives. If she only pays $40, did she drive any miles at all?
No.
No, so that's a 0. But if she pays $100, how do I figure out how many miles she drove? She had to pay 40 first, don't forget that. So 100 minus the 40 first, right? Which is 60, and then what do I do with that 60?
Divided by 0.65.
Divide it by 0.65. And what do you get? Like 92 point something?
92.3.
So we're going to go with whole miles, so we'll say 92. So she can drive the least amount, 0 miles, the most, 92 miles. If she's moving farther away than that, then she's kind of out of luck. She's going to have a problem. Because she doesn't have enough money to do it. Figure out the one that they gave you the most information about first. Okay, skip down to number 3. Richie has $20 to spend on a cookie bouquet for his girlfriend. The cost of each cookie is $1.50. So the cost, or the money, and number of cookies. I'm going old school, that's not a hashtag, that's number of. Okay, so those are your 2 variables. Which one depends on the other one? Okay, how much he pays depends on how many cookies he gets, all right? So this is dependent, this is independent, which makes this the range, and this the domain. You have to have that in your brain to kind of figure these out. If you don't have that in your mind, you're not going to be able to figure out what's reasonable. Okay, you may just write some randomness down, but that doesn't make it right. So I'm going to have domain, whoops, wrong one. Domain is cookies, and range is money. Which one again do I know more about? The range. I know more about how much money, right? He could spend $0, which would make his girlfriend mad. Or he could spend up to how much?
20.
$20. We know this is the Y, arrows go to the left. He could spend anywhere between 0 and $20. Once I have that, I can figure out domain. If he spends $0, how many cookies is he getting? 0 cookies. I know X is in the middle. If he spends $20, how many cookies can he get? What do you do? 20 divided by 1.50. You can get 13 point something, but he can't have a third of a cookie on that bouquet or she's really going to be mad. It's like a broken cookie. Okay, so total of 13 is the most he can get.
Bouquet's only 12, right?
Busted.
Well, like that would be a dozen, yeah. 11, yeah.
Okay, what's my phone number?
Okay, so that is
First I want my 20.
the notes for today. If I can get this to turn off.